Welcome everyone to the third Pivot panel session, and greetings from the Netherlands, the city of Rijswijk, to the audience online. My name is Pejman Shoeibi Omrani. I'm working as a senior scientist at TNO, and I'll be moderating the session today entitled Building Bridges from the Lab to the Fields, the Role of Large-Scale Lab Facilities in the Next Generation Geothermal Pilots. Pretty long name. So I'm very happy that today we have three panelists, one joining us from United States, and we have two from the Netherlands, three experts representing academia, the research institutes, and industry, and let's see how will be their views with respect to these topics of the larger scale facilities. So first, before we deep dive into the topic, I would like to have a short introduction from each of our panelists. I do it very democratic, so based on alphabets. I would like to start with Ivo Vos, Senior Business Developers from TNO. So Ivo, can you introduce yourself, and looking into the title of the panel session, Larger Scale Facilities, how is your work and role related to these larger scale facilities?
Thank you, Pejman. Yeah, sure. So indeed, my name is Ivo Vos, business developer for TNO. I have two hats. One of the hats is for the Rijswijk Center of Sustainable Geo-Energy. That's a large-scale lab facility here in the Netherlands, in Rijswijk. So I do business development, project acquisition activities for that facility. And on the other hand, for the market heat and cold, I'm also active as a business developer. So.
Excellent. Yeah, and I think a great idea also to have the event here, where we are with just walking distance to the Rijswijk Center for Geo-Energy. Now let's go another few kilometers to the city of Delft. Our second panelist from academia, Martin Bloemendal. He is an assistant professor at TU Delft and also a senior researcher at KWR. So could you please introduce yourself and again make a link to the larger scale facilities?
Yes, my name is Martin Bloemendal. I work in Delft at the Delft University of Technology, where my topic is underground thermal energy storage, high temperature heat storage, but also heat and cold for heating and cooling of buildings. So that's my main topic of research, and also, of course, education. And my link to today's session here is the large-scale infrastructure that we're currently developing at our campus. We'll currently are drilling geothermal well to 2.2 kilometers depth that will supply the campus of heat and also a part of the city of Delft. The heat that is being produced in summer we don't use directly. We store that in the shallow subsurface to be able to additionally supply peak demand in winters. We have a heat pump facility. Today we will submit a Horizon Europe proposal to also use that heat pump in summer to boost the high temperature heat storage with peak power production that we have in summer. So yeah, we're really creating a full scale facility where we both knock down CO2 emissions from the TU Delft and the city of Delft, but also develop these technologies, do research on the fly while we are developing these projects.
Excellent. So I also studied at Delft in 2009. At that time, they were talking about, well, soon there will be a geothermal well. It's very great to see this is happening, and actually it's happening also just few meters from my office, so it's always nice to see this drilling rig.
And this is even fast.
Yeah, exactly, yeah. In action, I'll get back into that. So now let's go like thousands of kilometers to the other side of the world. We have Rob Klenner from States joining us. He's the Director of Geothermal Innovation and Technology from Baker Hughes, so we're also representing the industry. Rob, please, short introduction from yourself and also linking to the large-scale facilities. How do you see your work in it?
Yeah, thank you very much, and I wish I could be there, but I think that's the power of Pivot, to be virtual as well, and to the virtual audience to get all the updates on the industry and geothermal energy. Like you mentioned, I am with Baker Hughes, one of the technology leaders within our geothermal growth area. And I also serve as the Wells to Watts Executive Director. This is a joint industry partnership that we formed with oil and gas customers. And we're very excited in what we're doing in downtown Oklahoma City, where we've drilled a test facility. We have a test well. Now we're converting it into a high temperature geothermal flow loop. And the great part about this is it's downtown Oklahoma, where a lot of people don't know a lot about geothermal energy, and we can get customers in, we can get people from the community in to learn about geothermal, and we're commissioning this lab at the moment. So our first projects will be around closed loop technology. We only have a single well, so we'll be looking at thermal efficiency transfer in the downhole environment, how it can be used in oil and gas wells. And we'll also have an organic Rankine cycle there as well. So we'll have the full subsurface to surface capabilities for geothermal.
Excellent. Thanks for the introduction. So, I mean, bridging the gaps, bridging the, making bridges between the industries, and here we're talking literally about building bridges between lab to the field. And I would like to start with Ivo. I mean, we are very close to the Rijswijk Center for Sustainable Geo-Energy. Can you tell us what is this center and what's really unique about this center?
Yeah, thanks. Yeah, let's start with calling it RCSG. It makes it a little bit shorter.
Yeah, we don't have time, so that's good.
Yeah, exactly. So, yeah, it's an open technology innovation center for geoenergy applications to accelerate the energy transition. So what does that mean? There's a number of topics that we deal with. It's essentially a very large-scale facility with large-scale equipment. It's a facility that let's say we inherited from Shell. It's the old Shell Well Technology Center. In 2019, TNO took over operatorship of that center, supported by a number of parties, province, state, and industry, to utilize the equipment that is there for the energy transition. We have large equipment there to look at drilling technology, look at flow, look at all kinds around well integrity, all the kind of technologies that are required to, let's say, decrease the costs. We talked about in the various panels about how important it is to decrease costs, to also meet that demand in geothermal energy. So we do research around those topics. Innovation is the key word in that. Look at new technologies that we can mature through lifetime and make available for the market to deploy. Yeah.
Great. And one thing is like, if I want to also switch to Martin now, is that here we're talking about larger scale facilities, and at Delft you brought this example that this is actually the field case, which you bring it as a, I mean, I always say, you bring a huge laboratory to the students where they can experiment with it. Why did you take that step? Why not going from laboratory to the field? Why do you think that it's necessary to have, let's say, these sort of actual case pilots in order to go further with the innovation?
Yeah, so I think lab tests are also important to understand all the nitty-gritty details of all the processes occurring in the subsurface. But in the previous session, it was already mentioned a couple of times that we had mainly the greenhouses as users of geothermal in the Netherlands. But really the large potential for the energy transition lies within the urban environment. So we call our lab also the Delft Subsurface Urban Energy Lab. So really to test out all these different technology in an urban environment, and not only, so we're taking lots of cores, we're trying to understand in the shallow subsurface how the heat propagates in those layers and how we can optimally utilize those layers, but also the whole integration in such an urban environment. At a campus site, that's relatively easy still, but also the translation to how to implement such large-scale infrastructure to in an urban environment where it's difficult to operate. You have to all kinds of other interests to take care of. There's not a couple of greenhouses that use the heat. No, there are many different buildings with all different requirements. And so also from a system integration perspective, it's super important to test this at a full scale to be able to identify what are the key methods to utilize this heat that we can get from the subsurface.
Yeah, indeed. So that's indeed also one of the interesting things. I mean, so far we hear mainly the vision of the research institutes and academia, where we would like to perform research and we would like to really understand and apply them to the real case. And now if we want to go to Rob from industry, you put this program together, you put this consortium together, and the first pilot, I believe, in the city of Oklahoma will happen soon in this wells to watts program. So why do you as an industry see an added value in building such a, let's say, larger scale testing facility and pilots for the let's say this closed loop system?
Yeah, and it's really a unique opportunity for us in Baker Hughes. So this was a test lab that was actually built by General Electric as part of their global research network. Through the merger with Baker Hughes, we maintain this laboratory. And now we actually are co-located with the donation of the building itself to Oklahoma State University. So we have a very unique ecosystem that we're building with Oklahoma State. And I actually have students from the University of Oklahoma coming by tomorrow to get a tour and see what we're doing. The well itself is a test facility where it's only 300 feet deep. We're able to heat up and create artificial reservoir temperatures up to 450 degrees Fahrenheit within the system. But the uniqueness of how we structured this was really to get oil and gas involvement. So a lot of the players in the shale industry are headquartered in Oklahoma, Oklahoma City, and near proximity to other developers in Texas and the U.S. And then we also have Inpex, who's a large Japanese producer. But really getting the oil and gas industry behind geothermal, how we could take our current lab facilities and retrofit them for geothermal technology and development and testing. And now we have a full ecosystem of startups within the Wells to Watts program too. So really it's the ecosystem of co-location with the universities, the labs that we have with Baker Hughes, and now with industry involvement. The ecosystem can move very quickly with a private industry and the funding that we have to get projects done and moving fast within a year or two into the field.
So really bringing different stakeholders together, that's kind of really a key thing. And I think that also somehow, one of the questions is always when you see a larger scale facility, okay, looks impressive, but what is really needed to realize such a facility? If I come up with a good idea and if I can arrange the finance, is that enough?
Yeah, I mean, that's always the challenge, right? Is the funding that's available, and I think that's how the ecosystem can work together. Is the consortium of partners to put in some funding to de-risk this. We have the lab capabilities with the people, and very intelligent people is what's really needed in the lab to make this happen. So we know we have human resources. If everyone puts a bit of financial commitment in there, and then we also have resources from the startup, and so it's frameworking that project together, agreeing on it, and moving very quickly. So, moving beyond the financial hurdles, now we can get into the technical hurdles. But by corporations really providing in kind, it can move things very quickly.
And Ivo, maybe from the business aspect, sometimes seeing the business case in realizing such a large scale facility is not straightforward. How would you see this? Do you see it as a challenge? What should people do if they want to realize these larger scale facilities?
Yeah, definitely it's a challenge. And there's no doubt about it that these facilities, they're costly. They're costly to run. It's costly to set up new installations or test setups, whatever you need to do. But I think it's indeed, the crux is in what you say, is the business case. There has to be a business case for a certain technology or a certain innovation to mature and to become market ready. And that's what these large scale labs, they fill the gap between, let's say, someone inventing a prototype to deploying that prototype, well, obviously deploying the matured technology in the field and companies making money from it.
Yeah.
That's the field that we play in, I think.
Martin, we already touched a bit about the Geothermal Delft, the Geothermal Delft project, and the whole timeline around this, right? So I think it took more than a decade or 2 decades. I'm not sure, but I mean, for us, waiting for it to happen, you know, like you want things to happen, but now it's happening. That's great. If you look back, do you think that it really requires such a long time to go from an idea by 2 students to a real setup that is now happening? Or are there things that can be done differently to speed up the process?
Well, looking in hindsight, things can always go quicker, right? And one key thing, of course, in our Delft project, what was really instrumental to make it really go forward quickly at some point was to make the real connection between the campus real estate, so the facility management that take care of the buildings and also the energy supply of the buildings, and the researchers. They were not, in the early years, they were not aligned for this project. But in the end, it turned out to work when the university as a whole realized, okay, this can serve 2 goals. The main core of our existence, research and education, and knock off CO2 emissions. And when that thought occurred, and people from CRE and from the research campus real estate started to talk with each other and together develop the project, then it went much smoother. And of course, you run into all kinds of practical issues and financial issues, but though you always have those in projects, I guess. But
yeah, right.
Maybe if I can add to that, again, what comes into play here is the business case, right? You mentioned planets aligned at some point. So if we look at our facility here in Rijswijk, we are ready to do, you know, lots and lots of parallel innovative technology tests, as many as we can run, and we push for that. But there needs to be also a demand or a pull from the market, a willingness and an alignment to move into some kind of development, some kind of innovation, and that's sometimes lagging behind from the large-scale laboratory perspective.
What is needed for that? Industry support?
Momentum, I would say. Yeah, so I think both Tino and we had quite some time that we're in a startup phase, but in Delft we really notice now that things are being developed. We have several flanking projects going on, and that really creates a demand for people that also want to be involved and have an idea. And in Delft, we focus on the different technologies, but also on the whole integration, and that really creates a whole vibe of people that say, "Oh, I have this idea. Could we test this?" So that momentum is really important, and also communicate and be open about what you're doing, and open about allowing people to also test stuff. I think that is key.
And Rob, coming from industry, do you also acknowledge these issues, or how do you look into it? I mean, you're coming from industry, so everything you do should make sense from business case. Maybe that's not always the case if you want to, for instance, conduct a research, but for yours, how do you see that?
Yeah, to some extent, Baker Hughes is a service provider, so we're really dependent on our customers as well. When we started thinking about what Wells to Watts was, or putting together this joint industry partnership, we knew we had to get oil and gas involved, and that was kind of our approach to it from a consortium perspective. At one point, our customers said, "Well, you guys have the lab, you can go do this yourself. So why don't you just go do this and then come back?" And that's just not the way we want to approach things. If we do this in isolation, we're going to be where we were two years down the road, showing them a little bit of change, but without that valuable input. So I'd say getting the right amount of industry involvement from different angles, whether it's a service provider like us, the operators, and then we have the startup technology ecosystem. And then we're also bringing in universities with, you know, what can we do with the data, or how do we take this to the field, and other ways of thinking about it from just maybe a one-dimensional approach. So really, it's a group of activities, everybody sharing their input, and then when we came together, they said, we're on this learning journey with you. We're here to learn, we're here to provide feedback. But that's really what needs to get done. It's a joint industry approach and getting that feedback right away.
Yeah, great. That's a good input. Ivo, please.
Yeah, just to add, because I think, and it comes in some of the things that Rob is saying and some of the things that Martin is saying, I think collaboration really is key here. And I don't just mean collaboration with industry or university or, you know, first, as a large-scale lab, you need to know what is required, what are the innovations we need to focus on. There's a multitude of things that we can move forward on, but which are the key ones? Let's find that collaboration between industry and research and applied research, if I say that. But then also collaboration between each other, between the facilities. It doesn't make any sense to replicate or duplicate, let's say, test setups that are built here in Germany and etc. Let's collaborate, and let's together help accelerate this transition. I think that is a key.
For sure.
Yeah, no, indeed. And I think that's an interesting aspect to see. This European, do we bound it to European, international, how to realize this? I think that would be a great topic maybe for Pivot 2024. So we are approaching the Q&A part. I have one short question to all the panelists, and before that, and after that we go to the Q&A. When we set up a larger scale facility, when we are demonstrating or piloting technologies in the field, we want to better understand how this technology or the system that we put in place is going to perform. When do we stop with it? When is it good enough? Because from research, of course, always room for more research. We want to better understand. We want to do more future works recommendations. But when do we think it's a stop? Okay, that's enough. What are the KPIs to say, now let's go to the field? Never could be an answer, but maybe very short, each of you can tell me, when do you think it's enough with a large scale facility test and pilots, and then we can go to the field?
We can already go to the field, and we should, because the energy transition cannot wait. So we should never, nobody should wait for us to come up with new, better things. We should already start, that's for sure. And I think also we should never stop. We should always try to make things better. I think we should be critical on what we present. What is the best of the new state of the art, so to say, in a lab environment, and with all these technical people that are really focused on getting every % of efficiency out of such a system. We should be critical. Okay, what is the bigger picture here? Is my system not too complex by squeezing out all these efficiency percentages? So how do we get the key energy savings in a robust way that will operate and be functional in practice? Because that's what we see, or what we've seen, for example, with the low temperature ATCE systems that we have in the Netherlands. They were on paper perfect. They would squeeze out 100% efficiency, no more CO2 emissions, but too many modes of operations, too complex hydraulic connections and control. So in the end, in practice, they wouldn't function at all. So make sure that we deliver to the field the key ways to save energy in a robust way, and that's what we should strive for.
Yeah, excellent. Anything to add, Ivo?
I don't fully agree, Martin, there with going, yes, we can do things in the field, for sure, but I do think that you need the facilities that we have to de-risk technologies. You can go straight into the field and start doing, I think in a previous panel, there was terminology around cowboys, okay, do all kinds of things. But I think what you want to make sure is that you don't put your technology, yourself, or let's say the heat transition at risk. So utilize the facilities to de-risk, and then at a certain point, when the technology is field ready, move over to test it in the field. I think that's how far we should go.
I meant with going to the field, the current state of the art. So that's, we should not.
We do have a good
Stop.
disagreement here, I think, for the happy hour. We can keep this for the drinks. Rob, would you like to add anything before we go to the Q&A session on this discussion? When is it good enough?
No, I think I agree with both Martin and Ivo.
But they disagree. How do you agree?
No, I mean, the reason we set our lab up was for the de-risking standpoint, right? We can go to the field, but I think we still need to do a bit of our due diligence and de-risking to do that in the laboratory. But I'm not going to be, scrapping the lab until we have 100 of these in the field, where really the field is the lab. And I think it's the volume of learning that we can get. And so what, it's an iterative approach, right? Where we're testing out our first one. We go to the field, we learn a bunch of things, and then we go back to the lab. And even in the lab, we're already thinking about what can we do in this test well environment from a materials or even a working fluid. We're already talking about how do we, go use supercritical CO2 or refrigerants? How do we tie that into the ORC system? We're already looking at other waste heat technology for thermal voltaics. So it's a combination, and it's again a iterative approach of how we're learning in the field, coming back, and that's what I was saying. I agree with both, because we have to both de-risk, but we also have to tune that efficiency as we go from the field back to the lab. So, and then once we get many of these done, I'm sure we'll still have a lab, but really the field becomes the lab because you're doing so many of these.
Excellent. So iteration is a way to make disagreement and change it to agreement. That's the way, because everyone is nodding. I think it's a great time to go to the Q&A session.
Anybody from the audience? Raise your hand. Can you pass this? Thank you.
Thank you very much for your presentation. A question: what do you see as crucial innovation topics for low enthalpy systems? Really, the key innovations we need to get the sector going, as Ms. Brommer was saying as well. And what role can you play in these key innovations with your labs?
Being honest, the first question is the one that I wanted to ask the previous panel, which you were part of it, because
then it was
the innovation in geothermal. No, great question. Anyone want to pick it up?
I can have a go. Sure. Yeah, no, indeed, great question, and I would say there are many challenges ahead of us. If we look specifically in the Netherlands, it's the mid-depth geothermal domain, unlocking that. So to unlock that, we need to look at all kinds of different things, the geomechanics in the subsurface there, but we talked about it earlier before today as well, lowering the drilling costs. How can we do that? How can we better drill with a smaller footprint in urban areas? So those are just three topics off the top of my mind. I think if we talk about the drink session later on, we can talk about this much longer. And I'm sure others have thoughts about that as well.
Martin?
Yeah, I think a key element is integration and seasonality. So storage is super important to be able to utilize the resource that we have maximum. That is a key element, that because most of the world is living in moderate climates, so we have to deal with these different demand periods. So that is a key element. Also integration. I mentioned already sector coupling, with how do we alleviate the power grid with subsurface storage or even production. So these kinds of things are, I think, super important from a system integration perspective. aside from many of the things that Ivo also said, which relate to the subsurface technology, making it cheaper, more efficient, more reliable, that is of course instrumental.
Excellent. And Rob, from your side?
Yeah, I agree with everything said. The only thing maybe to add is the societal side of things here too, where people just need to understand what geothermal is capable. And that's what I love about these large demonstration capabilities. They're not on large industrial sites. You can bring people through, you can educate them in what the different use cases are, especially in that low enthalpy environment. So I just have an exciting time when I bring people through our lab and show them the modular ORC unit and the well, and they see the footprint, and I tell them an ORC here can power 100 homes from the small kilowatt unit that we have, and then their light bulbs start to go on a little bit. So I think it's also a bit of education, and especially in these areas where geothermal isn't as developed as it is in other areas around the world.
Great.
Virtual audience. So if these were all here in person, we'd have happy hour brawls. So let's start with this one. So there's a viewer that thinks that emerging technologies like digital twinning is going to make facilities like this obsolete in the near future. What say you?
Can I take this question? Well, actually, I said it because actually this is my main topic that currently, together with our team, we're working on this, and also with industry. One of the things is that in the end, for all this digital twinning, you need data. And either you can get this data from the field, but often there are so many things happening at the same time that makes it difficult to isolate the processes. So in the end, we also have, let's say, projects and proposals where we want to create a digital twin of our laboratory facility, because there we can learn a lot. And then making that step to the field will be much easier, right? So now I'm acting as a panelist, but would you like to add?
Maybe if I can jump in, I think it's, I'm learning seeing is believing, because we have digital twins of what we've developed, and people just want to come in and see it to actually believe it. They want to touch and feel something. So yes, digital twins are very valuable, but people still need to see things with their two eyes and to make some decision.
Well, let's flick it around. Huh? These things just don't drop out of the sky. So, to get to the point that this person maybe envisages, we're maybe decades ahead, and testing, trials, whatever needs to be done. And this is also some of the topics that in the large-scale facilities that we have, especially also here in Rijswijk, that we're working on. Yeah.
Nothing to add.
Okay, here's another one from the virtual audience. How can you overcome barriers that exist with regard to intellectual property with these sorts of complex consortia?
Excellent question.
Yeah.
I can jump in if you want me to.
Rob, please, you start.
Yeah, so I think we're obviously with the technology ecosystem. Sometimes it's good, depending on the TRL level of the technology, right? It's really, we have a project level agreement on how we who owns the IP, set forth those expectations. And how you commercialize, but also how people benefit out of the IP and what you're developing within the consortium. So it is a very touchy subject, but it's something easy, I think, to have in a conversation of, what are you developing? How are you going to commercialize? And it's really, how does everybody benefit out of the development of the new IP? Because sometimes everybody doesn't necessarily need the IP. It's access to the IP to be a first mover in the space. So I think it's creative ways in how you can do this together.
I think, as Rob pointed out, it can be a touchy subject, but it doesn't necessarily need to be. You simply make an agreement and you work towards that agreement. If I look at our facility here in Rijswijk, we can facilitate, we can participate, we can, pick your flavor and it can be accommodated. That's what we're there for. Open innovation also means that partners retain their full IP to commercialize their own product whilst utilizing the facility. But on the other hand, we can also participate in the project and help develop the IP and these kind of things. So, I don't think it should be seen as a hurdle. It should be seen as something that needs to be discussed. Let's discuss it, let's put in an agreement, and off you go.
Yeah, in my experience, also not that big of a hurdle. I mean, we're obviously in the academic world, we're functioning with public funds usually. So everything, even with industry involvement, will be published openly. In a rare situation, there's really a big contribution from an industry partner that wants to keep innovation to themselves, but that's also a fair point, but that hardly ever happens, and it's certainly hardly ever touchy. So just make good agreements up front.
Okay, we'll take one more from our virtual audience, and then we'll leave the last one for the local audience, so you all come up with a really good one to end with. All right. Next up, to what extent well, this is actually directed at Rob, but I don't want to put you on the spot, Rob, because I think it applies to all the panel. To what extent has the government helped support your projects? So I think this was aimed DOE, wells to watts, Rob, but I think this could probably apply to everybody on the panel.
Yeah, so there is no government involvement for ours right now. It's just a joint industry partnership. What we'd love to do is how do we get the government involved if there's DOE funding available? I think that's something we can take our collective resources and laboratory spaces, not only just the test well in Oklahoma City, but other laboratories that we have to execute R&D technology, specifically high temperature technology, field pilots. So at this moment, we'd love to get involved, but I think that's one reason the government, forming this joint industry partnership is to move quickly as well, and not wait for government funding always to come out, so we can go do these projects at our own pace.
I think I mentioned it before. Running and operating these facilities is costly, and state support through whichever way is well appreciated. Here, the projects that we do, either in combination or support by EBN, the state energy company, or supported by RVO through subsidies. Those are key elements to undertake the innovation projects that we undertake here and to keep the facility running. So for the moment, I would not know what to do without state support, so yeah.
Yeah, same in Delft. I mean, also EBN and RVO via the state level, but also the province, the municipality, but it's also here in Rijswijk the case, I think. So, yeah, we need that support.
Last question of this session. So it's going to be a local question. Who's got one? Pressure's on. Y'all, I warned you like 5 minutes ago. All right, here we go.
I'll go again. Yeah, it's an interesting one, the innovation side of things, and it's something as part of the research at Queen's we've been mapping as the key elements of the geothermal environment, and technology cycling is one of them. But at some stage we have to move from technology exploration to exploitation, and the word business case was mentioned there multiple times, and I'm just wondering, what the thoughts on the panel are, because you seem to, in my discussions with people, you always come up against this wall with an investor where they basically want a one-pager saying, if I give you A to invest in technology B, what's my C, what do I get back, and what's the time frame for that? And yes, all the research we're doing into technology is great, but if we really want to accelerate the market share that technically isn't really there for geothermal at the moment, we need to get more aggressive on our investment into the economics of these, because as has been mentioned by the panel, like to get these consortiums up and running requires significant investment from governments, corporations, the private sector. But if we want to kickstart a private sector for geothermal, we need to maybe invest more on the actual business model side of it. So what are these projects costing, and what can the returns, be from them? Because if we want to develop the innovations we have, then we need to take it to market and make that case work. So I'm just wondering what sort of research is incorporated within your technology explorations to prove the business case, as an output.
Well, I can answer some of that. For example, the heat storage system that we're making in Delft, we're testing several new drilling technologies, new completion methods of these shallow wells for high temperature heat storage in shallow aquifers. That should gradually improve the business case in the long run of these systems. Just as an example of the things that we do.
Yeah, I think for many of the projects that we do, we try to look at NPV or lowest cost, levelized cost of energy, predict what it may be or could go towards moving forward. And then these are also, I think, elements that we look at how do they improve over time. So it is an element of each of the innovations that we look into. And those that have the best, let's say, forecast are those that we would like to put forward and mature.
And Rob, do you have any
Yeah.
final remarks to add?
Yeah, I mean, it's often difficult sometimes to define that business case, and I think that's where you may need to ask specifically what are, whoever you're talking to, what are they trying to get out of it? Because sometimes it's not dollars and cents. It may be some key understanding about geothermal development. So I think, understanding what key characteristics or performance indicators, what the test can provide, because they may not necessarily be dollars and cents until later down the road. And I think, when it comes to R&D, that should be very understandable. But it's what are you getting out of the information? How can they apply that information to their existing operations? And so I think it's an open dialogue at first. For us, it's key knowledge. It's leveraging multi-million-dollar laboratories that we have. It's leveraging some of our resources that we can bring into the projects. And then it's ultimately how they get to commercialize particular technology, which may not just necessarily be IP, but some other attractive commercial models that we can implement this. So I think it's the business case is also iterative, and it's a discussion as you learn more about deployment and the technology itself.
Excellent. So we are approaching the end of the session 3 of Pivot 2023 panels. I would like to thank all our panelists for the great insights and also all the audience for the questions. I think that the take home here is that we need to collaborate. The stakeholders has to collaborate. Running those larger scale facilities, they come at the cost. So the most important thing is to make sure next to the good idea that the business case is also justified. And with that, stakeholders, you can create a momentum to push this forward. Don't go to 2 digits behind the comma to get everything right, but make sure that when it's ready, go to the field and apply it. Thank you very much, and this is the end of the 3rd panel session.